Hi, this is Dr. Madhava. We're going to learn a little bit more about gravity and how it affects the Sun, Earth, and the Moon system. I think some of you might have already seen my previous video about the velocities and the forces that were acting on the Sun, Moon, and the Earth system. And in this class, we are going to study a little bit further about the interaction of these forces. Let's first recap what we have learned. We learned about the simulation of the moon around the earth, and we understood two things: how the moon causes tides because the force that is acting uh, upon the earth because of the moon, by virtue of the mass of the moon, that causes the tides. Not only that, but it also causes the wobbling of the earth, and this is the reason why we have the tides. And secondly, we also have discussed when we look at the sun and how the moon orbits the sun, the path of the moon around the sun. We had a chance to understand the concept of relative velocity, in the fact that even though the moon is rotating with uniform speed around the earth, its velocity around the sun keeps on changing because the moments it is in the same direction as the earth. The velocity vector for the moon will be large, and on the opposite direction the velocity will be small. And we also have discussed a little bit about I think we haven't. Let's look at what happens if we increase the mass of the sun, for example. Okay, as you can see, the mass increases, the gravity increases. And let's look at just the sun and the earth for the time being, and you can see, as you can observe, with the increase of the mass, the force of gravitation increases, and the earth actually tries to take a different path around the around the sun. And this is called slingshot effect. And as we can observe here, the forces, as you can observe here, the force, even though the force of gravity, you can see as it approaches, the force of gravity is increasing. Okay, it's very high. And now you can see the force of gravity is very high, and as it recedes away from the sun, you can see that the force gradually decreases. Okay, and if we increase the force to increase the mass of the earth to a certain level, so it actually might um, might cause a larger elliptical orbit. And sometimes if you increase the force too much, then it might actually blast into the surface of the sun. Now this is the effect of having too much of gravity, too much of mass. Let's look at the effect when there is not enough mass. Okay, let's when we remove gravity, what happens? Let's start with the standard system of let's reset, and let's start with the standard motion of, get rid of these two, and we understand this. And now let's remove gravity. If we take the gravity off, can you imagine what would happen? See, the earth is actually moving in a circular orbit around the earth, but in reality it is moving in what it thinks is a straight line. Okay, because of a massive object like the sun, the space around the sun, I mean, not just around the sun, even the entire solar system, the space is totally curved, and the earth is actually moving in a straight line in that curved space. And now when we remove when we switch the gravity off, so the earth is still moving in a straight line, only now it is moving in a straight line that is that in which the sun plays absolutely no role, because earlier the curvature of space actually made the earth move in a straight line. But here, when the sun is actually not there, you can actually see the tangential motion of the tangential velocity that is maintained by the earth, and the earth will continue to move along the same line unless encountered by any other planet or some other thing. So this is the effect of gravity. I hope this is clear what the effect is of having gravity, and hope to see you in the next lesson. Maybe we'll be talking about moon in the next class. Thank you guys. This is Dr. Madhav signing off from the Logic Academy. Thank you guys.